peace when I'm with you. But I love it. Oh, I can feel.
And welcome to the practice problems video for the shape of a graph. Okay, for this question we're asked to determine the intervals on which y equals 10x to the third minus x to the fifth is concave up or down, and find the points of inflection. So here our given function is f of x, also known as y. So f of x is equal to 10x to the third minus x to the fifth. Okay, so concavity and points of inflection have to do have both to do with the f double prime of x. So let's find that first. So we have f prime of x, we have to go through that, is 30x squared minus 5x to the fourth, right? And then if we derive once more, we have f double prime of x is equal to 60x and then minus a 20x to the third. Okay, so our goal here is to find the critical points in a sense. So where f double prime, so our second derivative, is equal to 0. So if we try to do that, we can factor out a 20x. So we get a 3 and then minus an x squared, okay, equals 0. And we can factor this further, right? So we get 20x times radical 3 minus x and radical 3 plus x, okay, is equal to 0. All right, so from here we can say that our f double prime of x is equal to 0 when our x is either 0, a negative radical 3, or a positive radical 3. Okay, so these are our sort of like our critical points for the second derivative. So let's continue this on the next slide. So what we're going to do with those critical points is, so x is equal to negative radical 3, 0, and positive radical 3. And our f double prime of x, again, this is equal to a 20x. So I guess I'll write it out factored. So 20x, that's the 2, hold on. 20x, there we go. And then I'll just write the 3 minus x squared. Okay, so this is what our f double prime of x was. So now what we're going to do is sign analysis for the second derivative. Okay, so we're going to draw a little number line. We're going to plant our critical points on it. So negative radical 3, 0, and positive radical 3. Okay, and now we can pick our easy test points. So this is going to be kind of good because we don't have any restrictions, right? So we have a negative 2, we could write negative 1 here because that's in between. We can write a positive 1 and a positive 2. Okay, so let's plug these into our second derivative and see what signs we get. So f double prime of negative 2 is equal to 20 times a negative 2. And then we have 3 minus negative 2 squared. So on the outside we get a negative number, and on the inside we get 3 minus 4, so that's also a negative number. So that turns out positive overall. Okay, so we have a positive over that negative 2 here. That's our test point. If we try a negative 1, let's see what we get. So f double prime of negative 1, we have 20 times that negative 1 times 3 minus negative 1 squared. So here we get negative on the outside, but on the inside we have 3 minus 1, so that's a positive number. So we're going to get negative overall here. Okay, so this is a negative there. Now let's try 1. F double prime of 1 is 20 times a positive 1, 3 minus 1 squared. This is definitely going to be positive. So now we have positive again, we switched over. And finally, let's squish this one in. F double prime of 2 is equal to 20 times 2, and then times 3 minus a 2 squared. So then we have a positive times a negative, so that's overall a negative. So then we have a negative there. Okay, so see here, so this is our all-important number line, and let's analyze it now. So we see what we're looking for are the intervals of concave up and concave down, okay, and for our points of inflection. So I'll rewrite it on the next slide so we can see really what's going on. So our f double prime was given by, so here's our number line, and we had negative radical 3, a negative 2, negative 1, and then here's another critical point, 0, then we had a 1 and a positive radical 3 and a 2. So this was going to be, this started off being positive, then it switched over to being negative, and then we're back at positive and negative again. Okay, so first of all, points of inflection. Where does the second derivative change signs? So this is a critical point here, this is a critical point, and this is a critical point. So we see it changes from positive to negative here. Okay, I'll draw lines at our critical points so we can divide up those intervals. Okay, so anyways, So it switched from positive to negative, so that means that this is a point of inflection. That's good. It changed signs, the second derivative did. At 0, looking at this one now, we go from negative to being positive, so that also switched signs. So that's good. That's a valid point of inflection. Okay, and then let's see at positive radical 3, it switched from positive to negative, so this is also a point of inflection. So all 3 critical points turned out to be points of inflection, okay? And now, so let's write those. So points of inflection, or point of inflection at x equals negative radical 3, 0, and our positive radical 3. Okay, so we have that, and we also needed, where is it concave up and concave down? So what are the intervals? So concave up on what interval? So we're just basically looking for the intervals which have a positive sign in them for our second derivative. So here's one, that's one, and this is also a positive interval. So this is going to be, we're going to name this interval negative infinity, because it goes all the way to the left, right? And up to this line here, up to this line, which is given by our negative radical 3. So negative infinity up to negative radical 3. That's one of them. And now how we name this one is by its endpoint. So 0 to positive radical 3. So 0 to positive radical 3. Okay? All right, and then our other one is going to be concave down. So that'll be the remaining intervals. So concave down on, and that'll be the negative one. So here's one, and this goes from negative radical 3 up to 0, and then the other remaining negative one is all the way to the right there, and that one begins at positive radical 3 and then goes on to infinity. Alright, so that's basically it. Everything down here that I'm putting in a box, that is our answer for that problem.